So let's give a warm welcome to Kelly.
Hello everyone, can you guys hear me okay? Yeah. Just a tiny bit. Okay, I am really excited to be here to talk to you guys about my favourite thing, to talk about space. It is pretty large, and tonight is about small things, so I do have something more specific to kind of bring us back onto topic. So, what I'm going to talk to you about is a project that is in the works right now. It isn't a launch that's happened yet. You guys may have heard about it on the news, and it is all thanks to nanotechnology. So I can give you a bit of background, and then we'll go into how that is relevant to this evening a little bit more. Hopefully, yes. Okay, so we will explore a very, very large place, the universe. I think this is really cool because one of the most amazing facts that actually got me into studying astronomy is the fact that we are very, very closely linked to that universe. Some of you guys may have heard before that we are made from the same elements that are inside the stars. In fact, they were created by the stars. They had to explode and die for our planet to form, for us to form, to then stand here and look at the universe and try and figure out how it came here, how it works, are we alone, what's out there. And there's a few different ways that we do that. One of them is spaceships of all different kinds, shapes, sizes. They have many functions, but again, compared to the universe, they're pretty small, so we have to pick wisely. One of the biggest issues is we want to get stuff up there. People, cargo, things like water and food to keep them going while they're doing their experiments, and that means that we have to have large rocket ships. Here is a comparison of some of the space shuttles that have been used by NASA over the years. They're pretty large. The largest one is Saturn V, which is about 400 feet tall. They have very simple names: small, medium, heavy, super heavy. Keep it simple. And yeah, they're very effective, but the issue with that is the fuel. To get something that large out of the pull of the Earth's gravity and up into space, you need a lot of fuel. And the more stuff you bring, the bigger it is, the more fuel you need. So ideally, we want to start looking for alternative ways to deal with that, because the biggest limit there is distance as well. If we need to travel long distances, we're going to need to bring a lot of fuel with us and continuously supply that. Just to give you an idea, this is the largest spaceship that is in operation, the International Space Station. I was lucky enough to come across this image of its size compared to the stadium here in Vancouver. And again, we think of this as a huge international endeavour, but in terms of the scale of the places that we want to investigate and travel, it's actually pretty small. This has actually been in operation for over 20 years now, 365 days a year. An amazing feat of technology and sending people up into space to keep doing cool research projects. But there's an alternative. If we don't want to send people, we can send probes. There's all different kinds. This is just a few of them. There's been many over the years. I had put a big cross through Rosetta. You guys may have heard in the news. Controlled crash landing on a comet. That's pretty cool, but it has come to the end of its mission. Did some great science. And yeah, there's all kinds of shapes, sizes. They range from about 1 meter across to anywhere as big as a school bus. Again, pretty small compared to the universe. So, size isn't everything. Does anyone recognize this spacecraft? Yeah, cool, yeah, Voyager. So, it's very humble in size, but this spacecraft has traveled the furthest that any spacecraft has ever traveled from Earth, as far as we know. We're not counting other planets here. So it has been traveling, it's traveled 37 light hours, which might not seem like a very useful number. To give you an idea, that's 20 million kilometers. Light hours meaning that if you are traveling at the speed of light, then that's how far light can travel in 37 hours. So it's pretty far. It's actually, to be a bit more specific, it's what we call the edge of the solar system, which, depending on what astronomer you talk to, you can classify that a few different ways. This in particular is quite impressive. It's at the edge of what we call the heliosphere, which is where the solar winds from the sun, they create kind of a shockwave as they travel out. And at the point where that shockwave meets interstellar space and they're kind of equal and everything slows down, that's the edge of the heliosphere. That's where Voyager is now. But what if we could go even further than the edge of the solar system, to the nearby stars? That's what I want to talk to you guys about today. Just before I talk about this project, I have a video to play you guys by Carl Sagan, of course. Just to give you a bit of perspective, this is him talking about potential visits to Alpha Centauri. So that might be us visiting the planet ourselves, that might be, the star system ourselves, it could be sending probes. Either way, in 1997, this is how he felt about that.
By the time we're ready to settle even the nearest of other planetary systems, we will have changed. The simple passage of so many generations will have changed us. Necessity will have changed us. We're an adaptable species. It will not be we who reach Alpha Centauri and the other nearby stars. It will be a species very like us, but with more of our strengths and fewer of our weaknesses. More confident, foreseeing, capable, and prudent. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness.
Okay, so as you can tell, he was very, very passionate about the idea of humans going further than what we think we can do. This is Alpha Centauri. Anyone heard of Alpha Centauri before? Yeah. Okay, so it's our nearest neighbour. It's 4 light years away, which again is pretty far. The amount that light can travel, at light speed in 4 years, the distance that light has travelled would be to these guys. They are a binary star system, so they orbit around each other. And again, you may have heard in the news recently of a planet detected close to these stars that is very, very like Earth. We call that an exoplanet. I think it's mainly a rocky planet. This is pretty much all we know right now. We'd like to know, is there an atmosphere? Is there water? We know that it's similar size to Earth, but we'd like to go and check it out. So far, we don't really have many ways to do that. Except this new project. So to give you an idea of the distance, if Voyager was to reach Alpha Centauri, it would have had to have left Earth when humanity began. It would be getting there now. So that's about 1.8 million years? Let me double check. Million years. And yeah, that's the fastest spacecraft we've had so far. Now, looking at this new project, this is a $100 million project to send a nano-sized spacecraft to Alpha Centauri within 20 years. So within all of your lifetimes, hopefully. So the clause to that is it's technically 24 because it takes time for us to receive any information back to Earth. So traveling at light speed, they're 4 light years away, that would take 4 years. So in total, for us to get information back, it would be 24 years. But they are physically going to send things to the nearest star system. I have an animation from the Breakthrough Starshot project that will show you kind of how that works, and I'll talk through it as we go. Okay, so I said that fuel was an issue. We're going to use lasers. Not just one, many, many lasers, all pointed on the same spot on one of these spacecraft, which consists of a sail, kind of like the sail on a boat. It's very, very thin. I'll get to that in a moment. And this tiny, tiny little spacecraft right in the middle. So essentially, it does kind of work like the sail on a boat. Just how on a boat the sail catches the wind and it uses that momentum to push the boat along, these sails will capture, they will capture photons. So particles of light, they come from the sun, they're going to travel vast distances, they're going to get captured into that sail, and the pushing momentum of them being caught in that sail is going to propel the spacecraft forward. Luckily, in space, there's nothing. It's a vacuum. It's empty. There's no molecules. There's no tiny bits of dust in the air for it to be slowed down by. It's basically unimpeded momentum. And the more that you fire, it actually gathers speed. So this is going to travel at about 20% the speed of light, which is really impressive. Traveling at the speed of light has big limitations. I can give you some numbers as we go to the next slide. This way. There. Thank you. Okay. So this is Yuri Milner. He is one of the people that funded the project. So it's not funded by any government agency, it's a private company. They basically call themselves Breakthrough. They have all kinds of projects. I really encourage you to look at the other things that they're working on as well. I'll get on to who's on the board. It's basically a group of very passionate scientists that want to push for really cool projects. So he is holding up what they call the star chip. This is a model, so the thing itself is actually slightly smaller. So it's going to be about 1 centimetre across. On board this tiny spacecraft there is navigation systems, so to make sure that we know where we're going. There is communication, so we can send and receive messages. There is power supply, a little bit of propulsion if we need to. All it can do is kind of adjust course in case it's going to crash into something and we have the opportunity to save it. And 4 cameras. 4 of those 4 cameras are 2 megapixel cameras. And they are good enough if we can get close enough to take visual pictures of a particular exoplanet that we're interested in called Proxima b, the one that's been on the news fairly recently. So that's pretty cool. The sail itself, that's going to be about 1 metre across, but it is the width of about 100 molecules. It's very, very tiny, and nanotechnology is the main reason why we have such small components and why we're able to make such nano-thin materials. That might seem like a bad idea because it can get torn easily, but it turns out in space there's a lot of space. Things are about 1 mile to tens of miles apart, roughly, just tiny bits of debris. There's quite a lot of space in between everything there. And it could actually, even though it's thin, that doesn't necessarily mean that it's weak and it tears easily. It's very, very strong. And it can withhold anything from beneath a large asteroid. So, yeah, I think this will be okay. Just as a backup, they're sending hundreds of thousands of them at once. So we're going to get pictures. It's going to be great. So some of the people on the board, you might recognise some of them. Stephen Hawking at the top here. Yuri Milner, guy holding the satellite. He's described as an entrepreneur. He's got his hand in a lot of different projects, really cool stuff that's going on, and Mark Zuckerberg. So the people that are on the scientists that help him with this project, there's a lot of them. There's at least 26 main scientists and hundreds of PhD students. I wish I could mention every single person who's involved in this project because it's amazing, but that wouldn't be entertaining. So I picked a few. Anne Druin, she is Carl Sagan's wife. She was the creative director of the Voyager mission. So she got to decide what went in the capsule that they sent with them. There was recordings of human heartbeats, hello in every language on the human earth, some amazing music, all kinds of stuff in there. If anyone does find it, it's going to represent us. She was also creative director of Cosmos. And her and Carl Sagan fell in love as they were working on this amazing project, and a little anecdote that I like a lot is the heartbeat that was recorded was hers, and she likes to tell the story that Carl Sagan was recording it. She was sitting across the table from him, so the heartbeat that is out there is her falling in love with Carl Sagan. Very sweet, right? We also have Freeman Dyson from Princeton Institute of Advanced Study, Lou Friedman from the Planetary Society and JPL. He's involved in a lot of the building side of things. And Lawrence Krauss, he's a science communicator and professor at Arizona State University. Okay, so this is the target. This is Proxima b. I have to stress this is an artist's impression. Remember, we're going to get the pictures, we don't have them yet. It is in what we call the habitable zone, which the main thing we're looking for is liquid water. So you might have heard the Goldilocks analogy, not too hot, not too cold, just right. Just want it in that that area where liquid water can exist. There's all kinds of things that can support life. You can have liquid methane, liquid ammonia, but if we're going to start somewhere, we know it's water. It's the number one thing you need. So far, everything's looking good. But ideally, we want to go and clarify and potentially find a life supporting mechanism 4 light years away. So this is a picture of a few of the people on the team. I just want to stress that the cost of this mission, one, is fronted by a private organisation and some really passionate individuals. 2, thanks to Moore's law and nanotechnology, the fact that processing powers and sizes of components are continuously decreasing. This is going to allow so many opportunities in our future to pursue amazing challenges like going to the nearest star system and leaving our solar system. And just for a little bit of comparison, one of the satellites themselves cost about as much as an iPhone to make. So pretty cheap as well. Yeah, so just to wrap up the talk for tonight, I just want to leave you guys with this image. It's one of my favourites. So this is actually a local photographer who took some astronomy images of the Milky Way above Vancouver, used a bit of Photoshop, merged the two together. If we were in darkness tonight, this is what you guys would see on your way home.
Thanks, Kat. That was awesome. Spoke to all of my loves, including the Voyager mission, which is my favorite satellite, and everyone else's, right? I like to see them. But that was really great. I know that I was really inspired by when I heard about the Starshot project. And one of the things that is interesting to me when I hear about projects like this is exactly what you talked about, is that it is not a government-funded project. And there's many reasons for that, but I think one of the core reasons is that it's humanity going beyond our solar system, and not just one country like the United States. And even though if like say like NASA wanted to decide to do a project like this, which they would have to probably take 20 years for all the politicians to figure out and decide that they were going to actually allocate some money towards it, as opposed to just like some people with a lot of money to just do it. Do you have any thoughts on people, like say like Elon Musk, and he just announced that he wanted to go to Mars and actually start getting people there in the 2020s, 2060s. How realistic do you think that is for private companies and not like government agencies like NASA to accomplish these missions?
Yeah, that's a really good question. I actually was a little unsure how I felt about it for a long time. I was initially private company. Why are they getting involved? There's clearly some kind of motive here. But it turns out some of those companies, they're amazing at what they do, and NASA contracts them like to build their spacecrafts and to build things that we've never had built before, and someone has to take the lead on that. And like you said, NASA, I mean, their budget is 0.1% of the United States yearly budget. That's for everything. There isn't a lot of funding for space missions, and something like this and going to Mars, it's important. If you think about Man on the Moon, anyone around for that? I'm jealous if you were. Like, people watch that on a black and white TV and they were inspired. And scientists today, most of the people that are really passionate and sort of spokespeople for that kind of thing, Stephen Hawking, for example, that's what they were inspired by. And I think it's really important that someone is pushing for that. And these guys are taking the lead. Elon Musk, he has some really great ideas. He seems to be making things happen. I think 20 years is pretty reasonable. I mean, we're going to the nearest star system soon, so who knows? Yeah.
One of the little anecdotes I'll add to that I heard recently, that when NASA got to the moon, they of course 8 years earlier, when Kennedy made his famous speech that we were going to get to the moon and return people, they had no idea how to do it.
Yeah.
But that was sort of like the call to the scientists and to the young people to get energized and to like figure this out. So 8 years later, they did it. The average age of the people inside the NASA room that got to the moon was 26.
Yay!
So that meant when he made that speech, they were 18 years old.
Yeah.
So that's the key when we talk about like our future and like investing in our future. Those are the sort of things that I like thinking about. It's like when you're 18 years old, like you could be inspired to go to Mars. Does anyone have any questions for Kat? Put her in. So the question was, is there any worries because it's a private company about some of the information keeping private? Because I know like with NASA, like when they go on a mission, because they're a government agency, they have to release all of the information because they're a government agency. But a private company might not be able to.
Could be a concern. I can see why people might be worried about that. I think the main goal is photos, and the photographs that we get will be very good, very high definition. To give you an idea there, we would need a telescope on Earth that's about 300 meters wide to get the kind of images we're going to get from these cameras. The biggest one currently being built is 30 meters. So they're going to be pretty great images, and maybe if they do see something like there's life, 100% we can see it with this camera, that is a chance that they might keep that to themselves. But the thing that gives me hope that that won't happen, in fact, I really don't think it will, is the people that are on the board. Stephen Hawking's not going to keep that from you. Lawrence Krauss isn't going to keep that from you. They want this to happen. They've waited their whole lives, they've worked their whole lives for missions like this to happen. And personally, I feel more safe with this option than, I know governments have rules to share things, but we all know that doesn't always happen. So I have a lot of hope in this mission being for the people.
Absolutely. Any other questions for Kat? Well, let's give a round of applause to Kat Kelly. Thank you so much.